Time for one more example that, hey, yet again uses U substitution. What a shock. All right, so technique number one, I mean, I can spot it from a mile away. We're going to use a U sub. I don't even think it's a tricky one. I think it's pretty obvious that U must be equal to e to the x. And therefore du would be e to the x dx. Not shocking or tricky at all. All right, so this is equal to the integral by technique number one of sine to the 998 of u cosine cubed of u and then du, right? Because the e to the x in the front and the dx together there in the back will make du. All right, that's great, wonderful, marvelous. Now, I'm a little worried about the sine of the 998, but I figure if I keep going, I'll find a way through it. And that's what you should do too, right? Kind of be aware of the dangers and then think about where you're heading. All right, so let's use our powers of trig technique. So that'll be technique number two. We're going to break off, it's the powers of trig. And we're going to break off a cosine squared. It's really more a method than anything else. So when you have sine to the m of x and then cosine to the n of x, that's what you're taking the integral of. All right, so what we're going to do is we're going to break that cosine cubed. And we're going to break it into, so we'll leave the sine to the 998 of u. And I'm going to change it to cosine squared and cosine. Now, why would I do that? Well, because cosine squared is 1 minus sine squared. So now I'm going to take this one in the middle. I'm going to use the Pythagorean identity. I'm trying basically to get to another u substitution, slowly but surely. All right, so this is the integral of sine to the 998 of u times, and then cosine squared is 1 minus sine squared. And then I have a cosine of u left over, du. All right, now how in the world has that helped? Well, I'm basically eliminating everything but the one cosine because the derivative of sine is cosine. I'm heading to another lovely, lovely u substitution. All right, so I'm going to distribute this. So this is the integral of sine to the 998 of u. Oop, that's a u. Sorry. Minus sine 998 plus 2 more makes sine to the 1000 of u, and then cosine of u du. Okay, so then how in the world has this helped me? Oh, and this was all in here, right? So it was sine to the 998 minus sine to 1000 all in one parentheses, right? Because we distributed that, but we didn't distribute the cosine. And the reason I didn't distribute the cosine is because that's my next u substitution. Well, not the cosine part, but I'm going to use, and I can't use u again because I've already used u, so I'm going to have to call it v. V is the sine of u. Then the derivative of that is cosine, which will be this part right here. Sneaky, huh? All right, so that will get me, actually, I'm going to change that color to light purple because I don't want it to get confused with the Pythagorean identity work I did above. There we go. All right, so now I can rewrite this. This is v to the 998. So I'm taking the integral v to the 998 minus v to the 1000. Make sure your v's look different than your u's. And then that cosine of u du becomes dv. And again, it doesn't have to be V. It could be kind of any letter you like other than U. U and X. U and X are out because they already mean something in this problem, but any other letter. All right, well, that I can integrate. This is no problem. All right, so I'll just add 1 to the power. So V to the, oh, this was 998, sorry. So V to the 999 over 999 minus V to the 1001 over 1001 plus C. Okay, but V was sine of U, right? So this is sine of U to the 999. Oh, I better make that a little clearer, sorry. It's sine to the 999 of U over 999 minus sine to the 1001 of U over 1001 plus C. Whoop. Okay, but U was e to the x, so now I have to go back there. So I went from V to U, now I'm going to go from U back to e to the x. So it'll be sine to the 999 of e to the x minus sine to 1001 of e to the x. And there we have it. It was another double substitution problem.